So hello, we'll now see the power equipment and wireless network installations that have been made in Athens for our Energywarden pilot. Energywarden has been an ICT project of the FP7 research program and has been financially supported by the European Commission. And it was during this project that most of the buildingwarden.com technology has been developed. To provide an overview of the system and its monitoring and control aspects, let's start from this screen, which displays the user interface of the so-called EW bridge. EW stands for Energywarden. So this is quite a primitive interface, as you can see, and this is why we are currently building a more fancy one. However, the essential things are already shown on this early EW bridge interface. What we see here are data flowing in from the network to the bridge application and then pushed by it to the web database. And every time information scrolls across the screen, this means that data are coming in from the network and are being published to the database. The frequency of these scrolls will of course depend on the sampling intervals that have been programmed on all nodes. In our case, these programming intervals are set between 1 and 10 minutes, although there is no restriction to these values, and in principle there can be anything at all. So the EW bridge is a very important software component of the overall architecture, and there's a special video devoted to it. So we won't at this moment in time go into any more detail of the functionality behind all these buttons up here. We will, however, click on this child list button here on the right to access an illustration of our network. Here we can see all the nodes that are part of our pilot installation and the way they are connecting to each other. An important thing to note here is the blue circle around these nodes. When this circle is painted in blue, this means that there is no transmission problem at all. The node painted in blue transmits always successfully its data. And as you can see, this is currently the case for all our nodes. If for any reason there was a communication problem and the node failed to send its data to its parent node or to the gateway, in the case the gateway is the parent node, then the circle around it would be painted in red. Another important thing to note is the line color connecting two nodes. This is indicative of the signal strength. The signal strength is described by the so-called RSSI value, and this is something that can be measured and is reported up here for all node connections. A green line, such as for example the line between 6 and 4, is indicative of a high RSSI value and a very good signal. A red line, on the other hand, for example like the line between 11 and 4, indicates a not so strong signal that does however get through. Otherwise, if node number 11 failed to transmit its data, then it would have been painted in red, the circle around it. The network routing implemented here is based on a quite advanced dynamic protocol that has been also published in the literature. There's a key paper, and this is available online at our buildingwarden.com site. There is also a 15 to 20 minute video detailing this functionality of the advanced dynamic route protocol that has been implemented in this case. So what we see on the visualization screen are 13 overall nodes. Node 00 is the gateway, and all the rest from 01 to 12 are assigned various data collection roles. One of them is also assigned a control functionality. In this way we will demonstrate that a completely distributed concept is in place where network roles can be programmed to carry out by themselves control functions without the need for any centralized device. Nodes in our case are scattered in the 3-floor building. We have a basement, a ground, a first and a second floor where we are currently located. You can notice that most nodes cannot directly report to the gateway. The building has a 30 cm reinforced concrete slabs, and this makes it pretty impossible for a node at the basement to reach the second floor where we are now. Other more convenient routes have then to be found, and this is one of the main jobs of this dynamic routing protocol that we have implemented. Last, as we will see, some of the nodes have been deliberately placed in a very difficult environment. Difficult from the point of view of transmission. This we did in order to check connectivity limitations. We will see this better when we tour the nodes and the equipment behind them one by one. So let's start our small tour.